So today we're going to talk about how to calculate to know drops per minute. Yes, that is when you're going to give a certain medication, but it requires drops per minute, or there is a required time where you have to give this, this drug. So we want to know drops per minute. So we use this when you're going to give a certain drug, but there is a certain time that is required, but you don't know how am I going to make sure that this drug is given in the exact time that is required. So we're going to use this formula to calculate the drops per minute, so that we know the required the drops that are going to come every minute, so that we get that exact time where we have to administer our drug. So what you have to know, first of all, you have to get the total volume required. Then you have to get time required. Then you have to know the dropping factor of the given set that you are going to use. So let me say that we're going to administer our quinine, and the quinine is given IV infusion, and this goes for 4 hours. So this is what we're going to use, and we're going to put it in our D5. We're going to put it in our D5, which is 500 mils. So since we're having our total volume required in mils is 500 mils, then our dropping factor we are going to use of 20. But remember this, if each giving set has its own dropping factor. We're having those which have 20, we have those which have 15, and those which have 10. So you have to mind about the giving set you are going to use, because also matters. Yes, so don't take it that every time you're going to use 20, you might find your dropping factor in your giving set is 10 or 15. So you have to mind about it. So we put it in our formula. The dropping factor per minute is equal to total volume in mils times the dropping factor. So it is in mils over time, but this time has to be in minutes, so you have to convert it in minutes. Remember, our time required is 4 hours, so we have to convert these hours into minutes. So we shall say 1 hour. Those who don't want math is coming back here. So 1 hour is equal to 60 minutes. Then what about our 4 hours, which we don't know? So you cross multiply, then we shall have our x as 240 minutes. So meaning we're having our total volume required, we're having a dropping factor which we're going to use of 20 drops per minute. We're having the time is 4 hours, then when you converted it into minutes. So when we put it into our formula, per minute is going to equal to our total volume is 500 mils times the dropping factor of 20 over our time in minutes is 240, meaning that our dropping factor, when you calculate, is going, when you try to calculate, is going to give us 41.6, approximately 42 drops per minute. So you're going to go on our giving set in our bottle. So you start counting those drops, which when you see they are fitting to 1 minute, those 42, then that means you have to start administering that drug. So thank you for following and liking this video. So like the video, share it to others so that we share this knowledge. So look kumala kuchikwatako. That one who haven't subscribed, please subscribe. You are losing a lot, and you will never see my videos again if you don't subscribe, you don't like. Comment whatever you want me to talk about. Talk it, come and do a video.